Okay, so now we're going to finish the factoring lecture, the third page of our handout, and it starts with number 14. Before we start though, I think we just might want to keep our formulas for the difference of squares and even the perfect squares handy. Perfect squares you can factor the same way you've always factored, and eventually you'll start to recognize the pattern to which these formulas will make sense. The difference of squares formula is very handy though. So number 14 says x cubed plus ax plus 3a plus 3x squared, and you want to factor that. Now you might try to arrange it so that you could get some various terms together, perhaps, or you just might try to factor it like it is. We can try to do it like it is. Our inside pieces won't wind up looking the same, but go ahead and try to factor by grouping without the t-square part, so you get to skip to the draw parentheses part. Here you can take out an x and you'd have an x squared plus a. Here you could take out a positive 3 and you'd have an a plus x squared. Now the inside pieces don't look the same, but in fact they are because of addition. Addition says, the addition property says x squared plus a is the same as a plus x squared. So then we can basically drop down that inside piece, pick an order that you want. I like x squared plus a, and then connect our outside pieces. So that is how you go about factoring that one. The next one looks suspiciously like a perfect square trinomial, but let's go ahead and factor it the old-fashioned way. We'd want factors of 9 that add up to be 6. How about 3 and 3? So we have 3x squared plus 3x plus 3x plus 3. Take out a 3x, you have an x plus, actually it's not a perfect square, x plus 1, sorry, ooh, I'm realizing that. Take out a 3 from the next one, you get an x plus 1, so it factors into x plus 1 and 3x plus 3, which is handy, and it is a perfect square because if I factor out a 3 from this one, you get x plus 1, x plus 1. I thought it looked like 1, but it has a factor of 3 driving it, so I should have factored out a 3 from the start. But again, not necessary. There's so many different ways to proceed in math. There are many different pathways to get to the same answer. This one's definitely a difference of squares. It can be rewritten as 5a squared minus 7b parentheses squared, like that. And according to the difference of squares formula, which is on the previous page, it says for any real numbers a and b such that a squared minus b squared, it can equal a plus b times a minus b. So ours can be factored into 5a plus 7b times 5a minus 7b, or vice versa, where you have the minus written first. So 5a minus 7b or times 5a plus 7b, or the way we have it here. The second one is also a difference of squares. It can be rewritten as y parentheses squared minus 6 parentheses squared, where y and 6 are your a and b terms, respectively. So this can be y minus 6, y plus 6. The bottom one looks like a perfect square trinomial. You want factors of 4 that add up to be 4, 2 and 2. So this should be x plus 2 times x plus 2. Taking the shortcut on that one. And you're done. After you do this worksheet, this factoring lecture, which is a total of 18 problems, you should feel pretty proficient in factoring. And it's something that you're going to have to do a lot through the whole semester. It's just a factor. So let me know if you have any questions about it.